Good morning, students. In the previous class, we discussed about an ideal solution and non-ideal solution and differences between the ideal solution and non-ideal solution. We are discussed in the previous class. In this class, we are going to be discussing about the types of non-ideal solutions. Non-ideal solution. What is meant by non-ideal solution? This already we are discussed in the previous class. Means non-ideal solution means which does the solutions does not obeys the Rolle's law, does not obeys the Rolle's law. Entire range of concentration are called as a non-ideal solutions. Are called as a non-ideal solutions. In this non-ideal solutions, again we are going to be classified into two types. That the first one we called as that is the non-ideal solution. That is the non-ideal solution showing that is the positive deviation. Positive deviation from Rolle's law. Then the second one we call as that is the non-ideal solution. That is the non-ideal solution showing negative deviation from Rolle's law. That is the negative deviation from Rolle's law. These the types of non-ideal solution. There are two types of non-ideal solutions. The one is non-ideal solution showing a positive deviation from the Rolle's law. The second one is non-ideal solution showing a negative deviation from the Rolle's law. The first we will discuss about the non-ideal solution showing the positive deviation. What are the characteristics of this? The solution, the non-ideal solution which shows the positive deviation. What are the characteristics of these types of solutions we will discuss now. That is, in this the total vapor pressure of the non-ideal solution. The total vapor pressure of the this non-ideal solution is greater than the or higher than the that is obtained the values obtained from the Rolle's law. Means the pressure. The first characteristics we are going to be say that the pressure, that is the pressure of the solution. The pressure of the solution is greater than the total pressure of the solution is greater than that is the partial pressures of the solvent and solute. Otherwise, we can say that is the vapor pressure of the solution. Vapor pressure of the solution is greater than the mole fraction of the pressure. That is P1 naught plus mole fraction of P2 naught. That is pure solute and the pure solvent. Pure solute and pure solvent. This about the first characteristic. Means the pressure is higher than the measured vapor pressure of these types of solution is higher than the measured from the Rolle's law. The pressure measured from the Rolle's law. In this second point, the interactions, that is interaction means, suppose if you are going to be taken as the solute is A, solvent is B. Otherwise, solvent is A, solute is B, your wish. If you are going to be interaction between the solute and the solvent, solvent is weaker compared to the solute interaction or solvent interaction. ಇಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ interaction, that is the interaction between the solute and the solvent is weaker than the that is the interactions of that is the solute and solvent molecule. If you are going to be taken as that is the solute is A. If you are going to be taken as solute is A, that is solvent is B. This interaction between these two molecules is weaker than the interaction between the AA or BB. Means in this what happens if you are going to be taken some example for this. That is, if you are going to be taken the ethanol, the mixture of ethanol and acetone is an example for the non-ideal solution which shows the positive deviation from the Rolle's law. Here, ethanol means the before the ethanol is containing the hydrogen bonding between the molecules. Means the hydrogen bonding between the molecules. When the acetone is added to ethanol, that the acetone molecule enters the in between the ethanol molecules. At that time, what happens? It breaks the hydrogen bond. At that time, it's having a tendency to escape the molecules, either ethanol molecules or acetone. It's having a tendency to escape. The molecule is more. At that time, it is we can say that it is a vapor pressure is automatically going to be increases. Therefore, these types of solutions shows the positive deviation from the Rolle's law. ಏನಾಗುತ್ತೆ ಫಸ್ಟ್ ಎಥನಾಲ್ ತಗೊಂಡಿದ್ವಿ. ಎಥನಾಲ್ ಅಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಇರುತ್ತೆ. ಆ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಇರೋದ್ರಿಂದ ಎಸ್ಕೇಪಿಂಗ್ ಕೆಪಾಸಿಟಿ ಕಮ್ಮಿ ಇರುತ್ತೆ. ಆವಾಗ ಏನ್ ಮಾಡ್ತೀವಿ? we are going to be adding acetone. At that time what happen? If acetone is added to the ethanol, at that time what happen? The breaking of the hydrogen bonds in the that is ethanol ಅಲ್ಲಿ ಇರುವಂತ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ಸ್ ನ ಬ್ರೇಕ್ ಮಾಡುತ್ತೆ. ಆವಾಗ ಬ್ರೇಕ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ then it's having a escaping capacity is going to be increases. ಅಂದ್ರೆ ಮಾಲಿಕ್ಯೂಲ್ ಎಸ್ಕೇಪಿಂಗ್ ಕೆಪಾಸಿಟಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಯಾವಾಗ ಜಾಸ್ತಿ ಆಗುತ್ತಾ ಅವಾಗ ಏನಾಗುತ್ತೆ? the vapor pressure ಜಾಸ್ತಿ ಆಗುತ್ತೆ. vapor pressure is going to be increases. Then therefore these types of solutions with this pair of there is solutions which shows the positive deviation, that is non-ideal. We will take some other example is carbon disulfide and the acetone, also example for the non-ideal solution which showing the positive deviation. Another characteristic is the mixture of this volume of the mixture. The volume of the mixture is greater than the volume of the individual sum of the volumes of the solute and the solvent. That is solute and the solvent. If they are going to be taken VA and VB or V1, V2, we can take it as if one is component 1 and component 2. You can take anything, that is V1 and V2. This what happens? The mixture is added. The mixture is going to be added. If we are taken the mixture of ethanol and the acetone, its the volume is increases. If we are adding the sum of the volumes of the ethanol and the acetone before adding. ಅಂದ್ರೆ ಎಥನಾಲ್ದು ಮತ್ತೆ ಅಸಿಟೋನ್ದು ಮುಂಚೆನೆ ನಾವು ವಾಲ್ಯೂಮ್ಸ್ ಏನಾದ್ರು ತಗೊಂಡು ಆಡ್ ಮಾಡಿರ್ತೀವಲ್ವಾ, ಸಮ್ ಮಾಡಿರ್ತೀವಲ್ಲ, ಆ ವ್ಯಾಲ್ಯೂಗಿಂತ the volume of the mixture is going to be greater. Means therefore the volume of the mixture is higher than the sum of the volumes of the two components. Then the enthalpy of the mixture, next point. The enthalpy of the mixture is greater than the sum of the enthalpies of the two components, that is H1 plus H2. That is the enthalpy of sum of the enthalpies of that is the component 1 and the component 2. This about the few characteristics of the non-ideal solutions showing the positive deviation from the Rolle's law. This about the now the total pressure of the mixture is greater than the sum of the partial pressures of the components. Like this only, they are going to be taken as the mole fractions in that also. That is the pressure of the mixture is greater than the sum of that is the product of the mole fraction and the pure solvent and the solute. This is going to be second point, that is solute-solvent interactions are weaker when compared to the solute interaction and solvent interaction. In the third point, is going to be says that the volume of the mixture is greater than the sum of the volumes of the components 1 and 2. Then the change in the enthalpy is greater than that is sum of the enthalpies of the component 1 and 2. These are about the characteristics of the non-ideal solutions which showing the positive deviation from the Rolle's law. In this graph, you can observe this is about the increase in the pressure of the solution. This is also increase the pressure of the component 2. Then this shows the vapor pressure of the solution. Means the graph is drawn on the vapor pressure and the mole fraction. Vapor pressure versus mole fraction. And that the vapor pressure is increases by adding by increasing the mole fraction of the solute. This is going to be this graph indicates that it is a non-ideal solution which shows the positive deviation from the Rolle's law. Next we will discuss about the non-ideal solution which shows the negative deviation from the Rolle's law. And study about the non-ideal solutions showing the negative deviation from the Rolle's law. In this, the characteristics of the non-ideal solution which shows the negative deviation from the Rolle's law, that is the pressure of the measured vapor pressure of the solution is going to be less than the sum of the partial pressures of the components. Sum of the partial pressure of the two components. That is if you are going to be taken that is the first characteristic, that is about the pressure of the total vapor pressure of the solution, that is the mixture, is going to be less than the sum of that is the vapor pressures of partial vapor pressures of the component 1 and 2. Otherwise we can be taken as the pressure that is the pressure of the mixture is less than the mole fraction of the pure component 1 and the mole fraction of the pure component 2. This is about the first point. In the interactions that is interaction between the AB is higher, that is stronger than the interaction between that is AA and AB. Means if suppose if here are going to be A is going to be taken as solute and B is going to be taken as a solvent, and that time the interaction between the solute and the solvent is stronger than the interaction between that is solute or solvent. Means if you are going to be taken the example, that is a phenol, the mixture of phenol and aniline. What happen if you are going to be taken the example for this is that is the phenol and aniline. Why is going to be increased interaction between the A and B, because it is going to be the phenol is added to aniline. At that time, that is the bond is going to be formed. The hydrogen bond is going to be formed between the highly electronegative element in the oxygen and the nitrogen present in the aniline. At that time, the intermolecular hydrogen bonding is going to be formed. This stronger the interaction between the molecules. At that time, the escaping tendency of the molecules is going to be decreases. Therefore, the vapor pressure of the solution is going to be decreases. ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಫಿನಾಲ್ ಅನಿಲಿನ್ಗೆ ಆಡ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ that is the bond hydrogen bond is going to form between the oxygen in the phenol and the nitrogen from the aniline. At that time, it's going to be the strong bonding. It's going to form the strong bonding. At that time, what happens? The escaping tendency is going to be decreases. The vapor pressure of the solution is going to be decreases. Then next point, we can say that the enthalpy, that is the enthalpy of the mixture. That is the enthalpy of the mixture is less than the sum of the enthalpies of the components. Two components means we are going to be taken as is less than 0. Generally, we can represent like this also. Then the enthalpy of the enthalpy of the mixture is less than the sum of the enthalpies of the components. Then the volume of the mixture is going to be less than the sum of the volumes of the two components. That is less than the 0. That's about the some of the characteristics of the non-ideal solution, which shows the negative deviation. In this graph, you can observe that the graph is drawn vapor pressure versus mole fraction. At that time, it's going to be this, whatever the line deviate, it shows the pressure is going to be decreases. The vapor pressure is going to be decreases. Means which shows why it's going to decreases, because the interaction between the two different molecules is going to be stronger. Therefore, the vapor pressure is going to be decreases. Then this shows the negative deviation from the Rolle's law. This about the characteristics of the that is the non-ideal solutions showing the negative deviation from the Rolle's law. The 4 points you have to remember. The pressure is going to be less than the sum of the partial pressures of the components. And the second point, the intra-AB, that is solute-solvent interactions is stronger than the solvent or solute-solute interactions. And the third point, you should be remember that the change in the enthalpy is less than the sum of the enthalpies of the two components. Then change in the volume is less than the sum of the volumes of the two components. Here, so many times asked in the examination, differentiate between the ideal solution, which shows the non-ideal solution, shows the positive deviation and negative deviation. Means you should be remember 4 points. In the positive deviation and negative deviation. Four points you have to be remember. The first one is the pressure. In the positive deviation, what happened? The pressure of this is greater than the sum of the partial pressures of the two components. That is total pressure, or the pressure of the mixture, pressure of the solution is greater than the sum of the partial pressures of the two components. In this case, the pressure is going to be less than the sum of the partial pressures of the two components. Total pressure of the mixture, vapor pressure of the mixture is going to be less than the sum of the partial pressures of the two components. In the second point, you should be remember that is the A-B interactions is weaker than the weaker than AA and BB interactions. Weaker, in this case, that is stronger. That is the AB interactions are stronger than, that is AA and BB interactions. This third point you should be remember that there is a mixture. There is a change in the volume of the mixture is going to be increases, means greater than the 0, means that is the volume of the mixture is greater than the sum of the volumes of the two components. Otherwise, we can directly write that is the change. That is the volume of the mixture is greater than the 0. Then volume of the mixture is less than the 0, means that is the volume is going to be decreases. Then the enthalpy, the change in the enthalpy, that is the enthalpy of the mixture is greater than 0. In this case, the change in the enthalpy of the mixture is less than 0. Then example for this is ethanol and the acetone. Example for this is a phenol and aniline. This is about the differences between that is the non-ideal solution showing the positive deviation, non-ideal solution which shows the negative deviation. This about the next class we will discuss about the azeotropic solutions and the qualitative properties we will discuss in the next class.